Section 6.1 The Standard Normal Distribution. First, we have to define the density curve. The graph of any continuous probability distribution is called a density curve. And any density curve must satisfy the requirement that the total area under the curve is exactly 1. Because the total area under the curve of any density curve is equal to 1, there is a correspondence between the area and the probability. Uniform distribution. Properties of uniform distribution. The area under the graph of a continuous probability distribution is equal to 1. There is a correspondence between area and probability, so probabilities can be found by identifying the corresponding areas in the graph using the formula of the area of a rectangle, area equals height times width. A continuous random variable has a uniform distribution if its values are spread evenly over the range of possibilities. The graph of a uniform distribution results in a rectangular shape. The graph of a uniform distribution is a rectangle. Everything from A to B will have exactly the same height. To find the height of this rectangle, we are using the formula 1 over B minus A. The area under this rectangle must be equal to 1. Example 1. During certain time periods at JFK Airport in New York City, passengers arriving at the security checkpoint have waiting times that are uniformly distributed between 0 minutes and 5 minutes. Find the probability of randomly selecting a passenger with a waiting time of at least 2 minutes. I have a uniform distribution from 0 minutes to 5 minutes. My horizontal scale representing minutes, so I have 0 minute here and then 5 minutes here. My A is 0 and my B is 5. I want to find the height of the rectangle, that is 1 over 5 minus 0, which is 1 over 5. I want to find the probability that the waiting time is at least 2 minutes, which means I want to find the probability of x is greater than or equal to 2. 0, 1, 2, 3, 4, 5. So 2 is right here and I want it to be 2 or greater. I want to find this area. So to find the area of a rectangle, I take the base times the height. So my base is 3, 1, 2, 3, and my height is 1/5. And my answer is 3/5 or 0.6. Next, we have normal distribution. If a continuous random variable has a distribution with a graph that is symmetric and bell-shaped, we say that it has a normal distribution. So this is the graph of a normal distribution. It has a bell shape and that is symmetric. Your mean is always right in the middle of a bell shape. In this section, we will focus on a standard normal distribution. A standard normal distribution will have exactly the same shape as a regular normal distribution. However, the mean is always 0 and the standard deviation is always 1 if you are in a standard normal distribution. So I have my mean equal to 0 and then my standard deviation is 1. And my scale, the horizontal scale, is representing the z-score. The area under the curve must be exactly 1. Example 2. A bone mineral density test can be helpful in identifying the presence or likelihood of osteoporosis. The result of bone density test is commonly measured as a z-score. The population of the z-score is normally distributed with mean of 0 and standard deviation of 1. So these test results meet the requirement of a standard normal distribution. A randomly selected adult undergoes a bone density test. Find the probability that this person has a bone density test less than 1.27. So these are normally distributed with mean of 0 and standard deviation of 1. So this is my graph with my mean is 0 and my standard deviation is 1. I want to find the probability that the person has a bone density test score less than 1.27. This is 1, this is 2. 1.27 is somewhere in here. This is 1.27 and I want everything less than. So everything on the left side. I am looking for the probability that my z is less than 1.27. I am going to use StatCrunch for this. To use the normal distribution calculator on StatCrunch, you're going to click on Stat, Calculators, and choose Normal. So in this problem, my mean is 0. My standard deviation is 1. I want my x to be less than 1.27. Compute. This is my probability right here. My answer is 0.89795768. And since there are no instruction on how they want me to round, I am going to round it to 3 significant figures. And I got 0.898. Example 3. Using the same bone density test, find the probability that a randomly selected person has a result above -1. So this is the graph of my problem with mean equals 0 and standard deviation equals 1. They want me to find the probability that the person has the result above -1. -1 is right here. And I want it to be above -1. So -1 above is everything to the right. So I want to shake the right part of the graph. In this example, my mean is still 0. My standard deviation is still 1. I want the probability of x is greater than -1. This is my probability. And I got 0.8413445. Round to 3 significant figures. Example 3. A bone density reading between -1 and -2.5 indicates the subject has osteopenia, which is some bone loss. Find the probability that a randomly selected subject has a reading between -1 and -2.5. So -1 is right here and -2.5 is right here. I want everything in between -1 and -2.5. In this example, I want to find the probability in between. So up here, I'm going to click on this bar right here, say between. Mean is still 0, standard deviation is still 1. I want my lower end to be -2.5 and my upper end is -1. And this is my probability. My answer is 0.152445559. And I'm going to round it to 3 significant figures, which is 0.152. Notation. Probability of A less than Z less than B means the probability in between A and B. Probability that Z is greater than A means the probability that the Z-score is greater than A. Probability of z less than a denotes the probability that the z-score is less than a. In a continuous probability distribution, greater than and greater than or equal to give you the same answer. So you can either just use greater than or greater than or equal to. Similar to less than and less than or equal to, and similar to this one as well. You can use one or the other. Critical value. For the standard normal distribution, a critical value is a z-score on the borderline separating those z-scores that are significantly low or significantly high. The notation for z-score is z of alpha denotes the z-score with an area of alpha to its right. If you want to locate z of alpha, this alpha is normally a 0.05 or 0.25 or a very small decimal. This alpha is going to be the area on the right. So it really depends on how small alpha is in order for me to locate my z. So if z alpha is right here, then this area is alpha. Example 4. Find the value of z of 0.025. So 0.025 is my alpha, which is the area on the right of z. So this is z of 0.025. This area is 0.025 right here. And I want to find that value. So basically, probability of z greater than that question mark is equal to 0.025. And my job is trying to look for that question mark. In this example, instead of finding the probability, you are trying to find this number in this box right here. So my mean is still 0, my standard deviation is still 1, my probability is 0.025, and I want it to be greater than in here. My z-score is 1.959964. My answer is 1.959964. If the question indicates the number of decimal places that they want you to round, then please follow the instruction. If not, for the z-score, we always round it to 2 decimal places, which gives me 1.96. Example 5. They're giving me the area right here, and they say this blue area is 0.2912. They want me to find this z. So I have probability of z that is less than whatever that number is, equals to 0.2912. And my job is trying to find that number. Similar to the previous question, we want to find the number in this box, and we have the probability of 0.2912, and I want to change the inequality to less than, and this is my answer. So I got negative 0.549888245, and there was no instruction, so I'm going to round this z-score to 2 decimal places, negative 0.55. Example 6. Assume that a randomly selected subject is given a bone density test. Bone density test scores are normally distributed with mean 0 and standard deviation of 1. Find P15. P15 means 15th percentile, which means you want to find the number with 15% below and 85% above. So say, if this is my P15, then this area is 15% and this area is 85%. And I want to find that number. It should be negative something because it's less than 0. So I know that my probability of z less than p15 equals to 0.15. And my job is trying to look for this number. In this example, I want to find the 15th percentile. My mean is still 0. My standard deviation is still 1. I have the probability of 0.15. I want the inequality to be less than. Compute. This is my answer right here. And I got negative 1.03643334. There was no instruction here, so these are the z-score, and I'm going to round it to 2 decimal places.